Hello everyone, welcome to course study on solid mechanics. In today's lecture, we are going to discuss the concept of core of section for a hollow rectangular section, for a circular section, and for a hollow circular section. So, for a hollow rectangular section, consider a hollow rectangular section of internal width B and depth D. Also, the external width is capital B and depth is capital D. Now, apply no tension condition to the given section we have. Therefore, from the figure we have an hollow rectangular section which has internal width B and internal depth small d. External width is capital B and the external depth is capital D, and for such a section we are going to apply the no tension condition. So all of you know that no tension condition can be given by sigma D should be greater than or equal to sigma B. Okay, therefore sigma D can be given by P by A. Sigma B is nothing but it is a bending stress, and by using flexural formula it can be given by M upon I xx into y. Therefore, for a hollow rectangular section, we have the area capital BD minus small bd. Therefore, direct stress can be given by P by capital BD minus small bd. Okay. In the same manner, bending stress can be given by P into E whole divided by capital BD cube by 12 minus small bd cube by 12 into D by 2, because value of moment is nothing but it is force into perpendicular distance. So E is nothing but it is the eccentricity, okay, and it is perpendicular to the force. Okay, Ixx is nothing but it is capital BD cube by 12 minus small bd cube by 12, and the value of Y is nothing but it is D by 2. It is the distance of extreme fiber from the centroidal axis. Therefore it will become capital D by 2. Okay, so this is the value of Y. Therefore, on solving this particular equation, we will have the value of E. On solving this particular equation, we will have the value of E, and that value of E is less than or equal to capital BD cube minus small bd cube whole divided by 6D into capital BD minus small bd. This is the value of eccentricity, okay, which we have to where we have to apply the load. Within that particular eccentricity, if we apply the load, the stresses will develop. Those are only compressive in nature, no tensile stress will develop. Okay, now this is the value of eccentricity about x axis only. Okay, if we consider about y axis, then the formula will become, according to that we will modify our formula. So Iyy will become db cube by 12 minus small db cube by 12, and the value of x will become capital B by 2. Okay, so again solving this particular equation, we will have the value of Ey. It is nothing but it is the value of Ey, eccentricity about y axis. So it will become capital db cube minus small db cube whole divided by 6b into capital BD minus small bd. So this is the value of eccentricity for the about y axis for a hollow rectangular section. Okay, therefore from figure again you can observe that if you apply the load within this particular area, the stresses which are developed, those are compressive in nature. No tensile stress will be developed anywhere into the column. Okay, but if you go beyond that particular, outside that particular region, then there will be the tensile stresses into the column. Okay, now we will discuss the core of section for a circular section. Okay, so from figure we have a circular section of diameter capital D. Okay, and for this particular section again we are going to apply the no tension condition. So all of you know that mathematically no tension condition can be given by sigma D should be greater than or equal to sigma B. Okay, so put the value of sigma D, it is P by A. Put the value of sigma B, that is flexural formula M upon I into Y. Okay, so for circular section we have the area pi by 4 into capital D square. So it will become P by pi by 4 into capital D square is greater than or equal to P into E divided by pi by 64 into D raised to 4 into D by 2. So the value of moment is nothing but P into E. The value of I, now here it is, don't consider Ixx and Iyy. For a circular section, Ixx and Iyy both are same. Both are same. Therefore, we have the value of I pi by 64 capital D raised to 4, and the value of y is nothing but it is d by 2. This value is nothing but it is the value of y. It is the distance of extreme fiber from the centroidal axis of the section. Okay, therefore it will become d by 2. On solving this equation for the value of E, we will have the final value E is less than or equal to d by 8. E is less than or equal to d by 8. So this value of d by 8 is nothing but this one. This is d by 8. This is d by 8. Okay, this is from the centroidal axis. If we have to calculate it for the total section, then it will become total eccentricity will be d by 8 plus d by 8. Okay, so it will become d by 4. So this value is nothing but it is d by 4, or it is already shown in the figure also. This is nothing but d by 4. Okay, so if you apply, it means that if you apply the load within this particular circle, then the stresses which are developed, those are only compressive in nature. No tensile stress will develop into the column. Okay, so this is the value of core of section for a circular section. Now we are going to discuss the core of section for a hollow circular section. Okay, so for a hollow circular section, consider a circular section of external diameter capital D and internal diameter small d. For such a case, we are going to apply no tension condition to the given section, so we will have sigma d should be greater than or equal to sigma b. Okay, therefore sigma d is nothing but p by a, sigma b is nothing but m upon I into y. Okay, therefore put the value of area for a hollow rectangular section. It will become pi by 4 into capital D square minus small d square. Okay, so from that we will have the value of direct stress in this way is greater than or equal to p into e whole divided by pi by 64 into capital D raised to 4 minus small d raised to 4, because this is the value of moment of inertia for the hollow rectangular section into d by 2. Okay, so we will have the final value of E. It is less than or equal to capital D square plus small d square divided by 8d. Okay, so this is the value of eccentricity from the centroidal axis in this way. Okay, if we have to find out for the total, then we have to add this value two times. Okay, we have to add again, so it will become d square plus d square upon 8d plus capital D square plus small d square upon 8d. So we will have the value of total eccentricity. It is capital D square plus small d square divided by 4d. Okay, so this is nothing but this value is nothing but it is the value of total eccentricity for a hollow circular section. Okay, so this is all about the concept of core of section. Okay, for a rectangular section, for a hollow rectangular section, circular section, and for a hollow circular section. Okay, so we will stop here. Thank you.